Hello, can you all hear me? How are you doing?
Fine.
Great. All right, it's nice to be in Berlin again. I just came down from Denver, actually, where I was at the DAO conference, and there it's really interesting to see like what people are imagining building with DAOs, and really see the purpose of like, hey, we need to actually make all the technology we're building really scalable. I see that there's a problem with the emoji, so we'll see how the slides look. All right, so I'm Joel, co-founder of 3box Labs, and we're building Ceramic. And so I'll sort of dive into some of the problems we've observed and seen over time, and how we can actually go about solving them. So if you think about in a blockchain ecosystem, where is your data stored? And if you think about it for a while, you realize that you have probably interacted with one or multiple blockchains, and you have one or multiple wallets. Your data kind of ends up in the transaction history of all these different blockchains. So we have like all this information available, but it's segregated across these different blockchain ecosystems. And you have maybe different wallets on like Ethereum, different EVM chains, but also like maybe Polkadot or Solana or whatever. And you don't really have like a cohesive view of your identity. This data usually contains like a lot of sort of rich social, definitely financial, and other sort of reputational context that can be useful in a variety of different applications. And it would be nice sort of if we can compose this data together, like use it across applications that are not only like tied to one blockchain ecosystem. Because Web3 devs tend to love composability. Like if we have a smart contract, to be able to compose on top of that for financial things, that's really nice. Can we do the same for data? Well, I think we can if we can create a shared metadata layer that sort of lives across and between all different blockchains, sort of like a mycelial network if you're familiar with like mushroom stuff. So how do we get there? Or why do we actually need this sort of metadata layer? What can we actually build with blockchains beyond finance? And the obvious thing that most people come up with is social media. We really need a substrate for communicating globally that doesn't polarize us. That's a big problem right now, that like social media actually tears us apart, and that's not really nice. I think if we can solve that and also like start building platforms that enables us to have like civic collaboration and scale civic collaboration, basically how we can contribute as citizens to the health of our whole sort of societies. So there's a cool project called Civic Abundance by Riz Lindmark. Basically they're building a dashboard for a city, and they sort of surface relevant metrics for the city. And there's also other sorts of like more out there or maybe more future-looking sort of ways to collaborate. I have two examples here on these graphs you can see in the middle. On the top you have the tech trees from Foresight Institute, and then what they want to try to do is basically map out how we can build really futuristic technology. So imagine you want to build a Dyson sphere. Like, what type of technology do you actually need as precursors to be able to build the core technology? So you probably need way better space propulsion. You probably need way better solar cells and other sorts of materials. So they want to build trees for like different types of technologies, and so we can more easily collaboratively map out how we get to these sort of sci-fi future things. Below that, we see the discourse graph, and discourse graph is really a way to, I should say, it's a scientific discourse graph. It's really a way to map out science and understand things. So you basically have a graph of questions, claims, and evidence. And all these things right now sort of live in a Web2 context, but these projects want to move it to like a decentralized substrate where it lives, it is verifiable, it's censorship resistance. You can see which user actually contributed to these graphs of knowledge. And I think what's really cool, if you tie this together with something like retroactive funding or Gitcoin grants, you can actually retroactively fund people who contribute to large-scale sort of scientific projects online. And you can see sort of like how these things compose, because you have maybe this tech tree, this tree of like how you get to some technology needs the discourse graph to be able to like map out and understand, pose questions about the relationship between technologies. So why don't we need authenticated actions, we need censorship resistance. Why can't we just put this on the blockchain? Well, blockchains tend to not be super scalable. They're really good for financial applications, and that's sort of what they're built to secure. In distributed systems, they use something called strong consistency, which means that essentially all nodes agree on the state at any point in time. And of course, this is great for financial things, like managing funds, funding public goods, using NFTs. But the fundamental limit of scalability in the blockchain is the block producer throughput. And that's basically the node that makes the block. That node has to process all the transactions that comes into the blockchain. And there are different kind of sort of approaches for trying to scale blockchains. One is just like, let's make bigger blocks. So that's sort of what Solana, what Arweave, what Celestia does with like different ways of providing guarantees about the availability of that data. There's also a proof of storage, which basically is fine with like the smaller block, but basically you can make deals with miners or other nodes in the network that, hey, store this big blob of data. But if you have like hundreds of millions of users that all sort of make small changes to their data at once, you can't really put that in a blob transaction because each individual user sort of signs and makes their own transactions. So you're still sort of hitting the limit of the block throughput. So what can we do to get around this? Well, let's look at Web2 applications. How do they scale like generally? So to your left here, you see basically Facebook architecture. They call it Tau. And it's just I think it's MongoDB. No, sorry, it's MySQL database that's just sharded. Then they have like layers of cache. And when you write to this database, it sort of propagates through the layers of cache down to the core database. But there's no like strong consistency, so you couldn't build like a financial type application on top of this. But it's really good for like this big social graph. Another thing on the right here, you see sort of like a representation of an event stream. So in Kafka, Kafka is like a distributed system for event streaming. And you can sort of think of a database, a table, as an event stream, because all the actions can sort of be converted into the event streams and then converted back into a table. And what's really neat about that is you might want to build a table based on an event stream, but you might also want to like take some other action or build some sort of different view on the data, maybe aggregate a bunch of different event streams. So the event stream as a primitive at the base layer kind of makes it much easier to compose at that base layer. And so we've taken some inspiration from these sort of things, and we've created something called Composable, which is built on Ceramic. Ceramic sort of handles the base, the kind of underlying event streams, and making sure they're authenticated, signed by the user. Composable sort of builds an index on top of that, and it's exposed as a GraphQL API. And so the way to think about Composable is sort of like as a graph database that is sort of decentralized, lives across the internet, and you can sort of choose which pieces of this database that you synchronize and that you help keep available. So you can think of it sort of as a blockchain that you synchronize, but you only pick and choose which pieces of data you synchronize. So the core sort of building block of Composable is a data model. So these are created with the GraphQL schema definition language. There is an example down to the right here. You see that there's a proposal. Imagine your proposal for a DAO, and that has a relation to a comment. So you can have relationships between these different models. And they're also discoverable and composable. So if I see this proposal and comment data models, I can actually create a new data model that's like a like on a comment. And so you can think of these, if you see the graphic top right, there is a model, the yellow pieces, and you can see each individual user's documents that they've created that conform to the model. So for example, we can see that user 3 created a proposal that both user 3 and user 2 commented on, and user 1 and user 2 liked one of the comments. So in this way, you sort of have an open write system. You don't actually need to have an access control system on the data model itself, but anyone can write to this system. So you can sort of like, at the database, at the indexing layer, you can choose which users you actually want to include in your data set. And each user sort of has one event stream per model that they're interacting with. And so taking these data models into something usable, in ComposeDB, we actually have something called composites that basically takes one or multiple models and makes it into sort of a view on top of this data. So a node, a ComposeDB node, basically indexes a subset of models. So you might only care about model 1 or 2, or model 1 or 4, and you can choose to only index these. You can sort of take existing composites that you find on the internet and pull them together or pull them apart. And this allows you to like sort of make queries across the models that you care about without having to synchronize the state of the entire network. And finally, one thing that we're adding to ComposeDB is the ability to sync historical data. So one example of this is Gitcoin runs their passport with stamps that they have for the grants round on top of Ceramic. So once they sort of like migrate to the new version of ComposeDB, anyone will be able to spin up a node and replicate the data set that they've generated. And anyone can spin up a node and actually use the Gitcoin passport data in their own application if they want to build their own sort of quadratic voting or use the Sybil score for something different. And this is really kind of what enables the composability. I can choose to spin up a node, index a subset of models, and now get shared access to this data. So how this works under the hood is that it's using event streaming. So an event stream in Ceramic is an independently verifiable event log, which means that anyone can spin up a node, synchronize this event stream, and validate it without having to validate the state of the entire network. So this is very different from smart contract blockchain, where you need to synchronize the entire blockchain to sort of see the state of one smart contract. So here, there's no interactions between event logs. They're sort of like independent. The way you authenticate to be able to write into one of these event streams is using your native wallet, so like your MetaMask or some wallet in another blockchain ecosystem. And essentially, I'm not going to go too much into details here, but you can basically generate a session key and sign in with Ethereum message, and now the session key is allowed to write to your data streams on your behalf without you having to sign for every single comment or like you make in the system, which is sort of like very much needed to give users a good experience. These event streams are totally peer-to-peer. You synchronize them, you run up a node, you say like, hey, I want to see these streams. You ask other nodes in the network, you synchronize them, and now you sort of can get a validated, or completely validate them for yourself. And one thing that I think is really interesting, so right now we use this event stream to build this ComposeDB graph database. But one thing you'll be able to do in the future is that we can potentially use this event stream to just build composable data pipelines. So imagine you have, you could have like something that looks at blockchain data and runs some computation and outputs that computation, puts that into an event stream, and some other system that maybe takes some real-world data, put that into event stream, and you can sort of have other data processors that just plug in to use an event stream as an input and use an event stream as an output, and you sort of have this verifiable history of like what the computations that was done over time. I think this can be like a fundamental building block for generally a data marketplace. All right, so now that we have these sort of building blocks, we have this ComposeDB, which can act as like a scalable substrate for Web3 applications and like sort of like a shared metadata layer across blockchains. We still have this problem of like, okay, I have these different wallets that on Ethereum, I have some data, and I have some data on Ceramic tied to my Ethereum address, and then similarly maybe for like Polkadot or Solana or what have you. So how can we actually like bring this together? Well, the way we've been thinking about identity in Ceramic is that identity is not really something that you get from an institution, a government, or whatever, sort of like the KYC approach. Someone says that, hey, this is a real person, this is a legitimate person. Instead, if you think about your identity as what it is in your real life, it's generally your relationships with other people, your relationship with the world, and how you interact with both of those. So why should it be different online? So in Ceramic, we see identity as an emergent property based on your interactions and your data. So to enable this, we sort of allow users to link their wallets together if they choose for that to be public or for that to be private. This sort of like allows you to build up contextual reputation. You can look at the graph of interactions from one or a set of wallets and sort of compute some reputation score based on that. In Gitcoin, what they're interested in doing, looking at this graph of like, well, first connected accounts, but eventually over time more and more data in the Ceramic network, is to calculate some sort of like social proximity score. And this enables them to do sort of much safer, much more stable quadratic voting. And finally, one important piece here is like, we want to be able to do selective disclosure. I want to be able to like tie all my accounts to one identifier, keep that private, and selectively disclose information to parties that I want to have a look at. So I think this sort of like notion of composable identity is really what can bring the Web3 ecosystems that are scattered across multiple blockchains together into one cohesive thing that we can use as our sort of main interaction point that we bring along into different applications. All right, so if you're interested in sort of trying out ComposeDB, we have a developer site called composedb.js.org. You can check it out. It's very new. We basically publicly announced it today. So if you want, check that out. And if you're interested in building these sort of highly scalable Web3 distributed systems, we're hiring. So you can find our community or go to our website in general. Thank you.
Thank you, Joe. Now, who has questions? Come on, don't be shy.
Hello. Do you have an idea what would be the best solution to have some kind of encrypted data and have a token-gated access? Is that also something you have thought of? Or like, for example, an NFT would basically, if you're the holder, then it would be the condition for you to grant access behind some, on a decentralized data storage. Is it something that could be achieved, or?
Yeah, I mean, I think it can definitely be achieved. So this is something that we've explored a bunch, and there's no straightforward, easy answer. Mm-hmm. If you want to do sort of access control based on a wallet, not a token, then in certain wallets, like MetaMask, there's a hack you can do, which is basically like sign a deterministic message, and then use the entropy of the signature to generate an encryption key. Now, this encryption key will live in your browser, and so it won't be like super secure, but at least you can have like access control based on wallet. For certain other wallet ecosystems, like in Polkadot, they don't have deterministic signatures, so you can't really use this trick. But then if you want to gate access based on an NFT or some other token, you need to use some sort of network and some sort of threshold encryption scheme. So there's a bunch of different protocols building this sort of thing. I think, so let's see, like we have threshold network. I think maybe Entropy is building something like this. Lit protocol is also building something like this. And so these sort of systems can do that, but they're all sort of they don't feel like completely ready yet. But threshold encryption is the way to do it, and that's just a matter of like, how do you trust the nodes that is holding the threshold keys?
Okay, thank you.